let's now move on to this. Let's now do 3 exercises. Okay, what I will do is like this. Whenever I ask you what the output should be, you should really pause the video, think about what the output should be, maybe without looking at the slides, because in the slide I got answer for you. But think about the exercise yourself. You might be tested a question like this maybe later. So it would be nice if you try to practice. All right, so now let's look at these 2 loops. So just tell you the difference. The initial value for version number 1, the loop counter is 0 initially. For version number 2, it is 1. The state condition, version number 1 is less than 100. Version number 2 is less than 201. For the first case, it's going to be plus plus, and second version plus equal 2, which means the loop counter is going to increment by 2 each time. All right. Pause the video and think about whether the output from the 2 programs should be the same or different, right? You can see if you can see the print line over here are exactly the same. However, would the output be the same? All right. Assuming that you pause the video and thought about it, the answer is it will be the same. Okay, because I will just tell you the conclusion right away and then I will justify it. Because the body of the loop is exactly the same. They do not depend on the loop counter value itself. Otherwise, it would be different right away, which I will show you later. Okay, and then number 1 and number 2, given that the body of the loop is the same, as long as they will be executed for the same number of times, the output will be the same. So now the question is, are we going to get the same number of iteration for both cases? That's pretty much like asking for this question over here. That's why it was so important for you to know. All right, let's see. Do a little bit of reasoning over here. For the first version over here, okay, version number 1, okay, and then this will be version number 2. Let's talk about these 2 versions. For version number 1, initial value will be 0, and then it will be true, right? And also iteration will be number 1. And also, let me do one more. This one just like a recap from the previous one. And then 1, and then true, and then it will be iteration number 2, and etc., right? So now we want to know at what point are we going to get the last one that's going to make it true. 99 should be the very last value, right? 99 is going to make true because 99 less than 100 will be true, whereas 100 is going to make it false. Agree? So 99, so you can see 1 corresponds to second iteration, 0 corresponds to the first iteration, 99 should correspond to the 100th iteration over here. And now you can see these are all the cases where it's going to make it true. How many are there? So we are talking about the size of the interval from 0 to 99, which will be 100, right? I explained this already. So that means welcome to Java is going to be printed out 100 times. That'll be for the first program. This one's easy. What about the second one? Second one is slightly trickier, but it's not too bad. Okay, the count initially will be 1. Okay, and then count less than 201 will be simply just true, right? Because there'll be 1 less than 201. This corresponds to the very first iteration. And then it will be incremented by 2 each time. So that'll be 3 over here. And then it will also be true, but this corresponds to the second iteration, right? We can have some formula over here, but I'll get there in just a moment. Okay. And then what about the third iteration? The third iteration will be the value for the count. It's going to be incremented by 2 from the previous counter value, right? It's going to be 5. All right. And then let me just do one more. What about the fourth iteration? It's going to be 7. 1, 3, 5, 7 corresponding to iteration 1, 2, 3, 4, right? I will get to the formula in just one moment, but what will be the last value that's going to make this count less than 201 true for the last time? It should be, okay, I'm going to put down the value over here. It's going to be 199 will be the last one, which is going to make it true. And then I'll put the box over here to about what which iteration this should be, okay? And then think about after this particular iteration, at the end of it, the value for count is going to be incremented from 199 to 201. 201 strictly less than 201 is going to be false. So we got this many guys over here about the state condition being true. And then what should this be? That's a question, right? And then, so after that, it's going to be false. Before I tell you what this should be, you may want to pause the video and think about it. All right, assuming that you paused the video and thought about it. Okay, let's see this. Let's see the relationship between this column over here and then this column over here. For iteration number 1, the count should be 1. For iteration number 2, the count is 3. And for iteration number 3, it is 5. Let's for the convenience, let's do a little bit of math over here. Math is really your friend when you want to do reasoning. Let's say over here, let's say iteration simply is simply I, right? So you can see the loop counter here is count. It's not really I, so I'm just choosing a different variable. When I is equal to 1, it corresponds to count being 1. When I is equal to 2, it corresponds to count being 3. When I is equal to 3, it corresponds to the count value being 5. Can you see any pattern over here? You want to see a relationship between the count should be equal to some function on I. Okay, you want to see what, you want to guess what it is? Well, you should be able to see, right? What about 2I minus 1? All right, 2 times 2 minus 1, 3. 3 times 2, 6 minus 1, 5. 4 times 2, 8 minus 1 will be 7, right? So exactly how I derive the formula, I just gotta by some observation on the relationship between the two numbers over here, and that's how I work it out. It's like a trial and error. Okay. So now, how do we work out what should be this? What should this be, right? So what we will do is we're gonna say 199. The count value is equal to 2I minus 1. So what should be the I? I should be 199 plus 1, 200, and then should be 100. Alright, guys, hopefully you're okay with this. So this is telling us we're going to get exactly 100 iterations, meaning that we're going to, so this will be the number of times this will be evaluated true before it is evaluated false for the last time. So we're going to print out welcome to Java over here also for 100 times. Meaning that welcome to Java 100 times versus welcome to Java 100 times, so they are the same. So the answer is over here. Alright, that's for this example here. I think the most valuable lesson for you to learn is to work out exactly how many iterations there are if the increments may not be exactly plus, right? So that's the main lesson for you. Alright, let's switch to the second exercise over here for the for loop. Okay, for the second exercise over here, similar idea, but now we just want to see over here, you can see we still got less than 100, less than or equal to 100, right? And the body of the loop is simply welcome to Java and then concatenated with the value of count, over here. Are the output the same or different? You may also want to think about iterations. How many iterations are there? But you know, before I get there, I can tell you that I can tell immediately the answer is going to be different. Let me tell you what the answer should be different. But why? Think about what's going to be the first line for this program here. Welcome to Java, and what's going to be the value for count for the first iteration? Initialized to be 0. It's going to be welcome to Java 0. What about the second one over here? The second one here, welcome to Java, that part is the same, but now the count over here initialized to be 1. So it will be 1. So you can see already the discrepancy, right? You can see 0 versus 1 for the very first line. So they are not the same. Okay, so that's different. But how many iterations are there? For this one here, it's going to go from 0 until you can already tell, right? What's going to be the last value of I? Oh, sorry, what's going to be the last value of count that's going to make it true? It should be from 0 to 99 for the first one, right? What about the second one? It's going to be from 1 until 100, right? That'll be the last value to make it true. And 101 is going to make it false, right? It's going to be from 1 to 100. How many numbers are there? Well, simply 100, right? It's easy. But if you want to apply the formula, 100 minus 1, 99, plus 1, 100. 99 minus 0, 99, plus 1, that'll give you 100. So the number of iterations for the two loops are the same. However, since the body of the loop, also the printout also depends on the output also depends on the value for the current count. So that's why they're different. All right. Hopefully you're okay. Let's now switch to the final exercise for the for loop over here very quickly. Each one of them, I can reveal the answer, and then but I can pause the video for each one of them. For the first one, start with 1 until 5, right? And then when I is incremented to 6, it's going to evaluate to false for the to exit from the loop. So what should be the output? Well, 5 iterations, right? This one should be easy. Hopefully you can see that simply 1, 2, 3, 4, 5. What about the second one over here? Initialize to be 1 over here all the way until 5. So 5 will be the last value to make this less than or equal to true. Also 5 iterations. So it should be 1, 2, 3, 4, 5. Agree? Okay, this one is also easy. What about this one here, the last one? Initialize to be 1 over here, and then less than or equal to 5. Okay, however, I++ happen first. All right, let's be a little bit careful here. Let's try to trace them very quickly. Let me just put the value over here. So here, I will be initialized to be 1. Okay, but it's not, however, it's 1, right? And then you can see I less than or equal to 5, the state condition is going to be true. So we're going to go to the first iteration, iteration number 1. Okay, so iteration number 1. However, you can see iteration number 1 will do I++ first. All right, and also, so this will be the I++ that's going to be executed first. So that will be 2. So that means 2 will be output first. All right, and then we go to the second iteration. The second iteration will start with I being 2. Okay, so 2 less than or equal to 5 is going to be true, and then so that'll be that'll be true. So that means we can go to the second iteration, and then second iteration is going to increment the value of I by from 2 to 3 first. So that means we're going to output 3. All right, and then we're going to check to see. Let me use a different color here. We're going to check to see whether the 3 less than or equal to 5 is also going to be true. So that means we're going to start with the third iteration with the I value being also 3. All right, so hopefully you're still fine. And then we're also going to increment the value of I by 1, right? It's going to be from 3 to 4, and then we're going to print out 4 over here, right? Let's move on very quickly. So we are very close, but it's really important for you to see how to trace this particular loop, which is a little bit trickier. Okay, let me do this. Okay, so now you can see at the end of the third iteration, the value will be 4. So now 4 less than or equal to 5 is going to be true. So that means we should really go into the fourth iteration, and the value should be actually 4, right? And then for the fourth iteration, you're going to print out 5 because you're going to execute I++ first, right? All right. Since like we're getting very close, but you can see 5 over here, 5 less than or equal to 5 is going to be also true. So that means it will still be true. And then we're also going to go for another fifth iteration with the i's value being 5. And then it's going to increment first. So from 5 to 6, it's also going to print out 6. Okay. And then, so now you can see 6. When we evaluate this again, 6 less than or equal to 5 is going to be false. That means no more iteration. That'll be about it. Okay. You can see here, just by telling how many iterations there are, you can see will still be you can just tell by seeing 1 less than or equal to 5 and also I++. That's okay. That means it's going to be 1, 2, 3, 4, 5 only. Okay. It's going to be value for the I is going to be 1, 2, 3, 4, 5 for each iteration. However, the output, that's something I would like to outline to you. But the corresponding output is going to be I++ we executed first. So it's going to be 2, 3, 4, 5, and 6. Right? That's the difference. Right? That will be an interesting case study for you. All right? Output will be 2, 3, 4, 5, 6. All right. So that's about the for loop exercise. So now let me talk about the while loop very quickly. So for the while loop, it is so important for you to realize it's basically equivalent to a for loop. So once I explain the equivalence, all the exercise can be done very easily by repeating what we just did. Okay, let's see this. We're going to have a loop counter over here outside the while loop, because the while loop only can only specify the state condition. Okay, so this part here simply correspond to you can think about, well, it's not really shown in the flow chart, but it's basically like an initialization. Okay, initialization. And that part is basically before you check the state condition for the very first time. And then you got the count over here, less than 100. So this corresponds to the state condition over here. And then you got the body of the loop over here. And you may just put a count plus plus over here at the end, or maybe somewhere in the middle, which we show to you, even in the for loop case, right? So that'll be the body of the loop. All right. So once we understand this, we're going to ask the same question. How many times is the state condition over here checked? And also, how many times is the loop body executed? All right. Let's now switch to this part over here directly. Okay. Very easy to see. I'm not going to repeat the trace table again. It's going to be very basically identical to the case of the for loop. Okay. We're going to so here I just simply use a J over here. J is initialized to be 3 over here. That's why you see 3 here correspond to iteration number 1, and also it's gonna go and also 4 correspond to iteration number 2, because we got J++, right? And also we got 5 over here correspond to iteration number 3. Can you see a pattern over here? Let's say iteration, since we already use a J over here, let me choose a different variable. Let's say iteration is simply I. I is 1, J is 3. I is 2, J is 4. I is 3, J is 5. Can you see any pattern here? Well, it seems to be J is simply equal to I plus 2. Don't you agree? All right. Okay. How exactly I came up with the pattern? I would say just by observing, right? But if you're going a little bit slow here, that's okay. You're just gonna come up with more example yourself and try to calculate them. All right. So that'll be the formula I have. And now I know that the very last value that's going to make this true will be 102. All right. Okay, so now that will correspond to 100. So which means we got exactly 100 iterations, right? So the test question could be, I just give you this fragment of code over here and ask you how many iterations there might be, right? That's kind of the formula you should really see, right? So you can see when J is equal to I plus 2. So I know the last value to really make it true is 102. So 102 is equal to I plus 2, meaning that I should be equal to 100. This tells me should be iteration 1 all the way to iteration 100. All right, so I got 100 iterations, and then it's going to be 100 plus 1. This will be the last, this will be the first time it's going to make it false, meaning that we don't have an infinite loop, right? So it's going to be 101. Okay, similar to what we did for the for loop, I just changed the example a little bit. Just make it a slightly different example for you. All right, let's do one exercise over here. This one is going to be very similar. Okay, again, we say welcome to Java over here for the first one. The body is really the same. And also welcome to Java. So now it's really about how many iterations there are, right? So we go from 0 over here to the last value that can make it true. And then given that we're going to do plus plus every time. So 0 to 99, right? That'll be 99 will be the last value to make it true. And for this example here, so initialize to be 1, less than or equal to 100, and then plus plus. So initial value 1 all the way until 100, that'll be the last value to make it true. Because once you get to 101, it's going to be false, right? How many numbers are there? Well, 100. We did this already. And how many values? 100. So it will be the same. Okay, I'm going to leave, it will be the same. I'm going to leave these two tracing tables clean over here for you. If you're interested, you can print it out or simply just do it on your tablets if you have one. Or you simply just copy this table here on the paper and then try to trace these two loops if you're not so sure. All right. Let me move on to the last exercise for the while loop over here. So this one here is going to be something very similar. Okay. I'm gonna make it simple. It's going to be different over here for the same reason that we did for the for loop. Because you can see initialize to be 0. That means for the very first iteration, 0 less than 100, true. So I'm going to say welcome to Java 0. And then for the second loop, initialize to be 1, and then 1 less than or equal to 100, true. So for the very first iteration, we're going to say welcome to Java 1. So that's already show the difference, right? As to how you actually calculate how many iterations there are, you can simply see these two intervals. It will be from 0 to, the last value to make this true will be 99, given that it's plus plus. And also, starting with 1, and the last value to make it to make this less than or equal to true, given that it's plus plus, will be 99. Oh, sorry, 100. Beg your pardon. It's less than or equal to, so that should be 100. All right, you with the same number of iterations. However, they simply print out different value for the count, so you can see the count is involved. All right, so that's the last example for the for loop and while loop. I hope you can really just review the basics from the Java tutorial videos and then try to get into the inside. I spoke about patternizing the loop changes over here. For example, I talked about a few examples already. All right, study that, and then before we move on to the last bit for this lecture,